It doesn't look like much, but we call it our legacy vac for legacy nutrients. So after weeds die, they sink to the bottom. We spray the weeds, they sink to the bottom. You get algae blooms when they die, they sink to the bottom. They create this kind of unconsolidated gravy-like muck, and it floats around. It'll flow through your fingers. It's just like gravy, right? So we took a very simple pump, put it into the muck to see if we could pump it. A 2-inch pump, we pumped it like the wind. It was consistency of like liquid manure on a dairy farm type of thing. So we tested it. We couldn't find anything that was toxic. We couldn't find any chemicals. Doesn't mean that they're not there, but they're in such small amounts they don't show up on a laboratory scale. All we found was a whole lot of nutrients and like compost, a lot of carbon. So what we did was we took a submersible pump that's it comes from Sweden. It's like a vacuum. It's 6 inches, 8 inches off the floor. It's on wheels, and we just wheel it along the bottom of the lake, and that stuff that moves, it just gets sucked in, and we spray it on the field.
So are you using that material to mix with the juice that you're making?
No. What we're gonna do is that's gonna work alone. We just brought it here to showcase it. So you have one machine that just pumps the gravy-like material, another machine that just pumps weeds.
That's what you were saying, because that wasn't in the contract.
Not in the contract,
in the demonstration contract. But you're doing it anyway, taking advantage of being out here.
Well, the Army Corps requested that we show it to them.
Okay.
They wanted to see like a real-life machine, what it's actually meant to do. FWC only wanted to do weeds, so we're just trying to make everybody happy.
Well, it's good, but while you're out here and you got all this equipment out here, it makes sense that you would try to test it if it wasn't too expensive or whatever the case may be. As a volunteer, I guess I should say.
Right.
On a volunteer basis.
Yeah, so this here is a regular irrigation reel they use in agriculture.
It's like a turret. It moves around. And,
right. Yeah. So we take this pump, this barge, we pull it out 1,000 feet, and you slowly reel it in at less than a mile per hour. The pump moves like a snail. And that way you pull the pump into the gravy-like material, into the muck, and it just vacuums off the bottom of the lake.
Do you have any idea how deep the muck is at this particular site?
Right here it's only a few inches, but when you get out in the middle of the lake, it's like 4 or 5 feet.
So you would need a larger pump if this would be something that we wanted to do.
No, you just need
over time.
You just need more pumps.
Chip at it, yeah, okay.
But there's about a foot or two of muck all along the marsh. So we're probably gonna, once the water levels come up, we're gonna start harvesting those weeds. We move the weeds and we go back and forth with the vacuum and vacuum the muck off the bottom. Right along the edge of the marsh from here, all the way down to the monkey
Remember I
bog.
had mentioned earlier about how they had to come in and scrape that edge that the lake was trying to create?
Yeah.
Well, it's still trying to create that.
Yeah. And which direction are we looking here now?
Go north, northeast.
Yeah. All right, great.
Yeah, so it's
how's this working?
amazing.
And how do you evaluate amazing?
Oh, by the analysis. So you take it to the lab, you figure out how many solids are in it, how much phosphorus is in it, how much nitrogen's in it, how much water's in it, right? Then you can evaluate how much you're hauling off. Basically, we're getting like maybe a quarter of a pound or half a pound in every 1,000 gallons. So you imagine a 1,000-gallon tank, you'll pull out about half a pound of phosphorus.
Which is a lot.
That's a lot.
Yeah, that's a lot.
There's a lot out there.
Yeah.
There's a lot out there.
And he's pumping 250,000 gallons a day.
Yeah.
That's where the...
On a good long day.
Yeah.
On a good long day.
And that's just from the muck.
That's just from the muck.
You're taking out a significant amount of phosphorus in there.
We got potential to.
Yeah.
And it's very simple. We're repurposing it. See, the whole goal is not to create another problem. It's to repurpose it into a commodity.
Yeah.
Right? See, when you think about something as a waste, you say, gosh, that muck is nothing but a waste, or the weeds are a waste. You're going to treat it like a waste. Go dump it somewhere, and you create another problem. But if you think of it as a commodity, then your brain starts to think, okay, how can I repurpose this? Because it's a commodity, right? So let's take it out and repurpose it on the land to improve the quality of the land, right? And then people ask the question, weren't you just going to flip the land? Well, no, you put it on an agronomic rate. So whatever the grass eats, that's what you put on.
Yeah.
Then you harvest the grass, you bale it up into hay bales, and haul it off to another location.
Now, is
and ERDIC, which is the Army Corps' Environmental Resource Agency. And then Nick is using an outside laboratory to provide the same results so that we can compare all four side by side when we're all done.
So that at some point we'll have a measure for what crop needs how much of the slurry
Yes.
yeah. Okay, great.
And you'd be surprised, most crops are very similar.
Yeah, yeah.
It's amazing. Like you take vitamins in your daily, you wake up every morning, do you ever take vitamins?
Yeah.
Do you know the plants almost need the same thing as we do? Just like animals. So when the plant dies, it's dumping all of its vitamins at the same time that it took throughout its life. And it turns into that muck. So when you take the muck out, you put all that back in the land, and that's what the cows need and the grass needs. Well, then when you take that, the cow, we eat the beef, and you flush your toilet, it winds up in the sewage treatment plant. You see what I mean? It's all connected. Everything we do is connected. So all we're doing is taking our part of the connection, human activity, and putting it back where it came from, getting it back into the cycle.